Okay, and here we are one more time. So we're looking at Module 3, Lesson 11, the most important property of logarithms, right? The most important property of logarithms. Use the table below to calculate. Let's make this a little bigger, why don't we? Okay, use the table, the logarithm table, to calculate the specified logarithms. So we got some here. So for instance, we got log of 80. So remember what ruled it, or law or whatever that we found out last time. It was, if we think about the log of base 10 of 10 to the, let's just say k, times any number, so we're going to call it x, that is equivalent to the log of 10 to the k power, remember that's to the base 10, plus log base 10 of x. And log 10 base of 10 to the k power, that's just k. So that's k plus log of x. So that's what we were talking about. So let's look at what we got here and see about writing it correctly. So I've got log of 80. 80 is 10 to the first power times 8. So that's what we're going to look at it as. 10 to the first power, first power times 8. So now I'm going to write that as log of 10 to the first power plus log of 8. So see, log of 8 is right there. And what's this going to be? Well, log, no base means it's base 10. So log base 10 of 10 to the first power is 1. Plus, and then I've got log of 8. That's 0.9031. And so that's going to equal 1.9031. Bada boom, done. All right, so what about log of 7 G's, 7 grand? Well, 7 grand is 10 to the third power times 7. 3 zeros, third power. So I'm going to write that as log of 10 to the third power times 7, which is going to be log of 10 to the third power plus log of 7. And log of 10 to the third power is 3. So I got 3 plus, and then there's my 7 right there, 0.8451. So that's going to equal 3.8451. So we got another one. We got log of 0.00006. Well, 0.0000, that's 4 zeros, right? Yep. 6 equals 10 to the negative. Because it's smaller than 1, I know it's a negative exponent. So how many moves did we make? 1, 2, 3, 4, 5. That's 5 moves. So 10 to the negative 5, right, times 6. So that's going to be the log of 10 to the negative 5 times 6, which is the log of 10 to the negative 5 plus the log of 6. The log of 6 is 0.7782. The log of 10 to the negative 5 is just negative 5. So I'm going to add these two things together. All right. So this is a negative. That's a positive. So that means it's a subtraction problem. So I got to take negative 5 plus that. I end up getting negative 4.2218. And I mean, you got to line your stuff up and subtract like that. So here we go with something else. Well, this one already has our stuff split for us, right? I've got log of 10 to the 27th power times 3. Now 3.03, it means the same thing, right? And it just so happens that 3's up there. So I've got log of 10 to the 27th power plus log of 3. And that's going to be 27 plus 0.4771. So that's going to be 27.4771. Pretty straightforward, right? And then the last one, we got a variable. What are we going to do? Well, let's think about it and do it the same way. So I got log of 10 to the k power times 9. The reason I'm not putting that 0.0 is because honestly it doesn't matter. Not for what we're doing. Maybe some other way that it would matter. It's not. Now what we could say though is that they wanted to make sure you knew that that was in scientific notation, so they put the 0.0. Scientific notation still qualifies if it's just 3 and it's just 9. That's not a big deal. But anyway, so that's going to be log of 10 to the k power plus log of 9. Well, log of 9 is right there. That's 0.9542. And what is this going to be? Well, log base 10 of 10 to the k power is just going to be k. So that's my answer. So we don't really have a solid one. We just have a variable plus that. So those are powers of 10 that we were able to split up, right? Because we had powers of 10, 10 to the first, 10 to the third, 10 to the negative fifth, 10 to the 27th, and 10 to the k. We got all of those, so we were able to do that. Well, let's keep going. Okay, so use your calculator to fill out the tables. I'm going to leave those to you, okay? You guys can use your calculator to fill out those tables, right? Right? All right, so now calculate the values, the following values, and do they appear anywhere in the table? So log of 2 plus log of 4. Well, there's 2, there's 4. So I've got 0.3010 plus 0.6021. Right? Well, if I add those together, let's see what I get. I get approximately, 0.9031, which is approximately 8. That is the same as log of 8. So log of 8 equals log of 2 plus log of 4. So is that showing you something? Let's write it again because it ran off the page on me. So log of 8 equals log of 2 plus log of 4. So is that telling you anything? Well, let's do maybe one or two more, and then we'll see what we got. Okay. So let's say we got log of 2. Well, I don't need to write it again. So what's log of 2? Again, that's 0.3010 plus, and log of 6 is 0.7782. So that is approximately, let's see, 1.0792. Well, let's look and see what log of 12 is. Just to be, just to be interesting. Let's just keep things interesting, right? So control log, we want base 10 of, what did we say, 12? And let's see, 1.079. Now notice that doesn't say 2 because it's 1 and then an 8. If we round up to 4 decimal places, 1 looks at the 8, is 5 or more, change the score. So that's going to be a 2. So yep, that works. So what do we got going on here? We got the log of 12, right, equals the log of 2 plus the log of 6. So do you see what's going on? Something tells me that this is going to be the same thing. Do you want to make a bet? Because these numbers that are being multiplied, right? If I take 3 times 4, that's 12. So the log of 12, which is this, should equal 3 plus 4. So let's see. 4 is 0, or 3 is 0.4771 plus log of 4 is 0.6021. So when I add those together, right, guess what I get? Approximately 0.0792. Pretty much. Now I say approximately because it doesn't equal it per se totally. You know, there's a little whatever. So do you guys see what's going on? That log of 12 is equal to log of 3 plus log of 4. So I'm able to take something and break it up into two factors, and then I separate those two factors and take the log of those values, and I get the same answer. So right here, so what would that mean? So let's just jump in and think. Well, so if I take the log of 6 plus the log of 6, that should give me what? 1.5663. So that's what that'll give me. So guess what the log of 36 is going to be? I can almost guarantee it's going to be that. I can almost guarantee it's going to be that. And why? Because the product rule for logs, if I have a log of x times y, that is equal to the log of x plus the log of y. And that's what I got going on. Now, before, when we first started, it was just powers of 10. Now we can see that it doesn't just have to be only powers of 10. So you see what I'm saying? Right? And let me pop this up on this calculator real quick so we don't have no doubt about what we're doing. Okay, so I got control log. It's log base 10. And what I say, 36? Boom. 1.5. Oh, shoot, that's a little different. That says 1.5563. Well, it's supposed to be approximate. So trust me, it's close enough. Trust me, it's close enough. All right. So it's approximately, that's what approximately means. It means it's really close, but not really. So let's see what log of, 18 is. So log of 18 is 1.25527. So that's what 18 is. Let's figure out what 2 is real quick. 2 is 0.3010. So I'm going to add those two things together. 3010 equals. So if I take those two and add them together, I should get 1.55. Whoa. Let's make sure we make it look so it looks right. 5563. And isn't that what I told you we get when we took the log of 36? So see, even though that was a little off, that's not off. So do you guys see what's going on here with the rule? And I guarantee you that the log of 3 plus the log of 12 should be approximately that same value, because 3 times 12 is 36. All three of those things have a product of 36. 6 times 6, 2 times 18, and 3 times 12. So does everybody follow what the logic is? It's the product rule for logarithms. It's this right here. That is the most important rule for logarithms. All right, so let's just look right here real quick. So I got the log of 14. So let's separate 14 into the product of two numbers. right? So that's going to be, say, the log of 2 times 7. Now, we've seen a couple of charts that got 2 and 7 on there, so we should be able to, at the very least, look back and see what they are. So log of 2 plus log of 7 should equal log of 14. So log of 2 is 0.3010, and log of 7 is 0.845. Is it 1? Yeah, 1. If I add those together, I get 1.1461. And guess what that is? That's approximately the log of 14. So I'm going to do one more, and then we're going to call it on this lesson, okay? And now they're asking you to do the same thing again. Oop, missed it totally. So I'll do a couple of those, and then we'll go from there. So like right here, log of 72, right, is equal to, say, because if I think about those charts, we've had 8 and 9 on them, so let's go with 8 and 9. We could go with different values, but I'm just trying to stick to the ones, like we could have said 6 and 12, and I think 6 and 12 is back on that chart. But let's just say 8 and 9. So that is log of 8 plus log of 9. And log of 8, according to my charted chart, is 0.9031. And then 9 is 0.95542. And when I add those two things together, I get approximately 573. And guess what that is? Let's see with the handy dandy calculator how close we are. So I'm going to go control log base 10 of 72. So that is 1.8573. And that is 1.8573. So you see what I'm saying? All right. I am not going to do these for you for the most part. I think I'll do 20, and then we'll call it. Because I want you to do these. You're using a calculator. It's just about putting it in there. Control the log button. The base that we're working with is 10. So that lower number, the one on the lowest number, that's always 10. And when I say lowest, I'm talking about lowest as in not how big a number is, but just lowest position wise. Okay. So that's going to be base 10 for right now. That's what we're just going to keep doing. Base 10, base 10. So I'm going to do 20, and then I'm going to compare it to what's 1 over 20. So I've got control log of base 10 of 20. So that is 1.3010. 1.3010. If you remember, that 2 is 0.3010, and then 10 is 1. So that's the log of 10 to the first power times 2, or log of 10 to the first power plus log of 2. That's what's going on here. So what is going to happen if I say it's 1 over 20? Well, let's see. So I got control log base 10, move over here, and right there. And so we say 1 divided by 20. So that is what happened. Whoa, is negative 1.3010. So that's a negative 1.3010. So what ends up happening is, let's think about it. What is that? Right? That is 1, let's see. I don't want to say that. let's see, 1 over 10 times 2. Yeah, that'll be 20. That'll be 10, goes into 2, 0.2 times, and 0.2 is, yeah, 0.2 is 1 over 10, or 1 over 20. So, yep. So this right here is -1, and this right here is 0.3010. So when I combine those, I'm adding the log separately, and that's what I get. So if you figure out these values, you should be able to figure out those values. And let me guess, you want me to do another one because, oh my God, Ferg, it's so hard. So let's do log of 5. If I plug it into the calculator, all right, so I got control, and let's show you the whole thing this time. So let's go back. Whoop, went a little too far back. So first, I'm going to make sure that I bring my control pad up to calculate. So the arrows, what? Dang it, I went to graph. There, okay, so I'm back there. Let's get rid of that. Okay, so I'm going to say control log. See what happened? My log popped up, and then it's down there at the lowest point. So I'm going to put 10 for my base. Now I'm just going to show you what I'm doing. So now, for this number, let's say we said we were going to do what? 5? You want me to do 8? What do you want me to do? How about 5? So I'm going to put 5 right there, and then hit enter. And that rounded is 0.698. Nope, is 0.6990, because that 9 looks at the 7. 7 is 7. 5 or more change the score, so I'm going to add 1. That's going to make that 90. So that is, for 5, it is 0.6990. So what do you mean, or what do you think that's going to be? Just think about it for a second while I take my time and punch in a couple calculations. So what do you think it's going to be? Well, let's see. It is negative, right? Negative 6990. So when we're not dealing with up to 10, right? We're dealing below 10. It's just going to make this number negative. Right? Because that is 1 over 10 times 5. And so here's my, that's my negative, and then that's my 5. Whoa, excuse me. Question. Anybody with a question? Too bad I can't hear you. I'm on a boat somewhere. So I'm going to leave this to you. I'm expecting you to do that. So exercises 6 through, well, the chart. I'm not worried about exercises 6 through 8 so much. I'm just worried about that. So please make sure you do that. All right. I'm probably going to have an exit ticket for you to do too. I wouldn't mind if you did these problems as well. So that looks like example 1 and example 2. Nope. Exercises 6 through 8, and I want you to do example 2. So I want this done, and I want you to finish that chart. So if you see some charts in lesson 10 or 11, I want them filled in. Okay? So I want you to do these. All right? And I'd like you to show your work the same way that I was showing work when I was doing this kind of stuff. Okay, I'm looking for that. I don't want you to just plug it in the calculator. You can use the calculator to check, but I want to see you break these things down. Check for a product of 2 numbers that are going to give me this, and then I split those numbers up and take the logs of those. Okay, that's what I'm expecting to see down here. Okay. Any question? Anybody question? Then I've got an exit ticket for you for 11. So I'll make sure that that's printed up for you. All right, I've got one more chapter that I want to touch on, and then we're done.